Hi, welcome to Texas Review online videos. In this video, we'll discuss about numbers and number properties. So we'll cover number types, number line, and number properties. What is a number? Let's try to understand what is a number with one example. So here the problem is how many numbers are there between 5 and 15. So majority of the students solve this problem like it is when you need to calculate numbers between any two numbers. It's like last number minus first number minus 1 will give you the number of numbers between any two numbers. So most of the students tend to answer it 9, but actually 5.1 is also a number, 5.2 is also a number. So there are actually infinite numbers between 5 and 15. So here the understanding of the word number is not complete. I mean, a student is answering 9. His understanding of the numbers is not complete. What actually is a number? In GRE, all numbers are real unless stated otherwise. So in this video, let us try to understand what is a number. Basically, numbers are classified into two types. Numbers are basically two types, real and imaginary. All the numbers that exist are real and the numbers that do not exist, for example, square root of negative numbers do not exist. Such numbers are called imaginary numbers. And for us in GRE, if the problem talks about a number, we need to consider it as a real number. Now, we don't deal with imaginary numbers in GRE. Now, let's see how these real numbers are classified. Any number like 2 is a real number, minus 1 by 2 is a real number, like decimal number 3.45 is a real number. So, all those numbers that exist are real. Now, the real numbers are classified into two groups, namely rational and irrational. Now, what is a rational number? Any number that can be written in the form P by Q and Q is not equal to 0 is a rational number. Any number that cannot be expressed in the form P by Q is called irrational. For example, here there is a number 3.45. This can be expressed as 345 by 100. Now here this is expressed in the form P by Q where P and Q are integers. So any number that can be expressed in this form are said to be rational. So you cannot express root 3 in the form P by Q, so root 3 is irrational. And pi, what is pi? Pi is the ratio between circumference and diameter of a circle, but we don't have two integers where you can express pi as P by Q, so pi is irrational. Now all integers, I mean integral numbers, are rational, and when you talk about decimals, we have decimal numbers. All the decimals that are recurring, that are, I mean, non-terminating and non-recurring are irrational, otherwise they are rational. For example, say 3.727272 so on. This is a recurring and non-terminating decimal. This can be expressed as a rational number, but if a number is not recurring or not terminating, for example root 3 never gets terminated and you don't see any pattern like this, so it is irrational. Now again, these rational numbers are two groups, so integers and non-integers. So non-integers are basically decimals. Integers are like we have positive integers 1, 2, 3, so on are called positive integers, -1, -2, -3, so on, or negative integers, and 0 is neither positive nor negative. So you need to be very careful if the problem talks about non-zero. Non-zero includes both positive and negative. If the problem talks about non-negative, now it is 0 and positive. The problem talks about positive integers. We are not supposed to consider 0. We need to consider only 1, 2, 3, so on, because 0 is neither positive nor negative. Now, all these numbers we are talking about can be represented on a number line like this. So this is called a real number line. You can represent any number in this number line. For example, where is root 3 on this number line? Root 3 is 1.7. Somewhere here we have root 3. Now somewhere here. And where is minus 4 by 3? Minus 4 by 3 may be somewhere here, which is minus 1.333. So any number can be represented on the number line, and every point on the number line represents a unique number, and no two numbers can be represented at the same point, or no points can represent same number on a number line. And for example, if A, B, C are three numbers on a number line in this order, then it's always A less than B less than C. So a number to the left of the given number on a number line is smaller than the given number, and any number to the right of the given number is always larger than the given number. So if it is given in the problem that these three are equally spaced, if these lines are equally spaced on a number line, then we can take it for granted like B minus A is always equal to C minus B. Now let's see what type of questions can be asked in GRE. For example, here is a question. In the above number line, the lines are equally spaced. What is the value of B minus A? We are asked to calculate what is B minus A. Now here it's given in the above number line, if the lines are equally spaced. Now lines are equally spaced. Now let's see. 1, 2, 3, 4. There are 5 spaces. Now how can we find out distance from this point to this point? Now if you want to find out distance between any 2 points on the number line, so subtract left side number from the right side number. That will give you the difference, I mean the gap between those two numbers. So here it is 1 minus 7 by 3, which is 1 plus 7 by 3 gives you 10 by 3. So the gap between minus 7 by 3 and 1 is 10 by 3. Now as this gap is divided into 5 equal parts. Now I am dividing this by 5. That gives me 2/3. So now we understand each gap is 2/3. In fact, B minus A is also distance between A and B, so which is nothing but 2/3. So the correct answer is the second option, 2/3. Let's see one more example on the number line. Now, as shown in the above figure, x cube, x square, and x are three numbers on a number line. what is the value of x. Now there are three numbers given. Unlike the previous problem, here the problem never I mean the information is not given like the numbers are the lines are equally spaced here. So if the problem doesn't mention that the lines are equally spaced, we are not supposed to assume that the lines are equally spaced, though apparently they are equally spaced. Now how to solve this type of problem? Now because here we don't have numbers, so we have to substitute numbers and find out what could be the value of x. Now, what to substitute? There are many values that we can substitute. So, whenever we have to eliminate options in this type of problems where we are not sure of any option and we can only simply plug in numbers and find out, the technique is plug in -1, 0 and 1 wherever they are applicable. For example, first option says x is positive. Now in this case I can plug in 1 because 1 is applicable here because x can be 1. So if x is 1, x cube is also 1, x square is also 1 and x is also 1, and we can't represent one number at three different points on a number line, so first option can not be our answer. Now second option says x is negative, so we can substitute -1 instead of x. When you substitute -1, x cube becomes -1 and x is -1, but x square is +1, and this is not possible because you can't have a positive number between two negative numbers, so ruled out, this option cannot be our answer. Now in this interval x lies between -1 and 1, so we can substitute 0. So when x is 0, x cube is 0, x square is 0 and x is 0, which is not possible on a number line. So eliminate this. Then in this case, -1 less than x less than 0, we are very sure, pretty sure that x is negative. So if x is negative, x square is positive and x cube and x are negative, and you can't have a positive number between two negative numbers. Even this cannot be our answer, so this must be our answer. Now this is the advantage of plugging in -1. If you want to fail a case, we use -1, 0 and 1, but this -1, 0 and 1 cannot be used to prove a statement, because if at all you have to prove a statement, we need to use a variety of numbers in order to prove that. Like 0, 1 by 2, 1, 2. This is the variety that should be used in order to prove a statement. But to eliminate, so we can simply use -1, 0 and 1 because they have a peculiar behavior when compared to other numbers.